Hello and welcome to Providers vSphere, the vSphere Working Group. We're going to talk about everything vSphere related and VMware. My name is David Von Thenen. I am a cloud native engineer at VMware. My Twitter and GitHub handle is at dvonthenen. My community participation includes Kubernetes, obviously, Cloud Provider SIG, and of course the vSphere Working Group here. My day-to-day activities include recently test infrastructure related things, CI to CD pipelines, and everything kind of related to the cloud. So that includes Azure, AWS, and the sorts. So the agenda today, we're going to cover some brief vSphere Working Group housekeeping items. Then we're going to do a very quick review of CPI and CSI. We're going to talk about multi-tenancy and resource constraints as it applies to vSphere and the virtual infrastructure. And then we're going to do a demo of vSphere role-based access and Kubernetes. And kind of the topic for this presentation here is like different deployment strategies you might be able to use for large and multi-tenant environments as they relate to vSphere users and Kubernetes clusters. So the first thing, vSphere Working Group housekeeping items. So where to find us? The working group meets every first Wednesday of every month at 9 a.m. Pacific. The Slack link is right there. And then we have meeting notes that are obviously publicly available. We talk about everything that's going on with CPI, CSI, and the meeting's obviously open, and you're welcome to drop in and post and add your topics for whatever you want to the agenda, and we can discuss that. There's also a VMware users group that meets the first Thursday of every month, so basically the following day at 11 p.m. Pacific. And then where you also might find some VMware fellow people in various areas of the Kubernetes community. So we're actively involved in SIG Cloud Provider, SIG Storage, and SIG Cluster Lifecycle. And I dropped the community links in the Kubernetes repo so you can find the times when they meet. So we're going to talk about the CPI and CSI projects. CPI is the Cloud Provider Interface, formerly known as the CCM or Cloud Controller Manager. Cloud Provider Interface, what it does is it allows you to hook Kubernetes into the underlying infrastructure and kind of make the underlying platform visible to Kubernetes. And it provides various mechanisms to do high availability zones, regions, load balancers, and whatnot. Just before this presentation, we cut a release of the CPI for vSphere, and it's version 1.2.0. It includes NSXT support, which is currently at an alpha. And then also we have YAML-based configuration that's now available, so you can express your cloud config using YAML. Also, we still continue to support the legacy any interface or the any configuration. The YAML configuration more complies with and is more in tune to what Kubernetes offers. The GitHub link is there for Cloud Provider vSphere. You can take a look at all the other bug fixes and other features that were implemented, just calling out the two big ones that are in CPI. So the container storage interface driver for vSphere. So container storage drivers, what they do is they provide storage lifecycle management for the underlying infrastructure or cloud provider that they're on. In case for vSphere, it has all sorts of capabilities for like create volumes or VMDKs, mount, unmount volumes for particular Kubernetes workloads. The latest release at the time of this presentation is 2.0.0. There is a release that's scheduled maybe a couple months after this. This latest 2.0 release includes support for read-write many volumes on vSAN, and then also extend volume capabilities for block volumes. If you're interested in all the other features that are present in the CSI driver for vSphere, the GitHub link is there. You can go ahead and look at the release notes that are available. I also would encourage you to look at the user group, vSphere user group session that was happened just 2 days prior to this. I believe it was recorded. It's by Steve Wong and Miles Gray. Definitely check that out because they'll cover a lot more various other topics relating to vSphere and VMware. So the first topic we're going to talk about is multi-tenancy and resource constraints. So just want to do a little quick level set for what we're going to cover and not cover in this presentation. So we're not going to cover multi-tenancy within a Kubernetes cluster, although some of the things that you're going to hear in this presentation can apply to that. And so it's kind of gets you thinking about different ways you can apply what we're going to talk about to doing multi-tenancy, doing zones and regions, and that kind of thing. When it comes to multi-tenancy in Kubernetes clusters, the recommended thing is to have individual Kubernetes cluster per tenant or per whatever your smallest organizational unit is, and even maybe Kubernetes clusters per user. So like when that user doesn't need his or her cluster anymore, they can go ahead and just reclaim it and or reinstall a new one to get the latest version. So what this presentation is going to cover is how to efficiently and effectively allocate vSphere compute resources. So the biggest problem when you're dealing with physical infrastructure is that you have constrained resources. You don't have an unlimited amount of hosts out there. You don't have an unlimited amount of servers that are out there in your data center. So the biggest problem is resource constraints. And because you have resource constraints, you have to have shared infrastructure. So you have vSphere clusters and ESX hosts that need to be shared among many different users, organization, business units. And some organizations might have a lot of infrastructure, a lot of ESX hosts, a lot of vSphere clusters, in the orders of hundreds, thousands. Even if you did have thousands, tens of thousands of ESX hosts and clusters out there, you still have the problem of if you were to dedicate, take the Kubernetes recommendation and dedicate like a cluster or a group of ESX hosts to a given user, if you have hundreds of thousands of users, you could easily run out of resource. And so if you can afford to have dedicated hardware per user, great. But in all likelihood, that's not really going to happen in reality. You're going to have to share your virtual infrastructure with other users. So how do we efficiently and effectively do that in vSphere and share all those resources? So the best and easiest way to do that is use vSphere role-based access and apply that to Kubernetes. So vSphere has native built-in RBAC for user access controls. I've dropped the link there for the documentation for vSphere 7. So kind of just to give you like a really quick overview, and logically what happens, you have normally you would have an admin account, they access the vCenter server, they see the data center, and in that data center you have two clusters A and B. Now, what you can do with RBAC and having user accounts for a given user instead of using the one root admin account, what you can do is you can create user accounts per user and then give them each individual access, so role-based access based on what they have access to. So like as in this example here, we have a tenant or user 1 who accesses vCenter server, sees the data center, and then sees his or her cluster called cluster A. And then you have a tenant user 2, access the vCenter server, they can see their cluster B. But like we said before, if you have limited resources, limited ESX hosts, a finite number of clusters, you can't have a user have dedicated ESX hosts or clusters, for that user, because you're talking then about a scale problem and you're going to have, it's going to be costly. And so the best way to do that is to share the virtual infrastructure and ESX hosts and clusters that are in your vCenter amongst many users. And so one way you can achieve that is doing RBAC, plus resource pools. And what a resource pool effectively is you have logical grouping of ESX hosts in the form of a vSphere cluster. And within that cluster, what you can do is you can carve out individual resource and create a logical container or a pool that users can create virtual machines within. And so that resource pool will constrain that user to X number of CPU cycles, Y number of memory, and then you can have multiple resource pools contained within a cluster. So basically carving out those resources in that cluster to multiple resource pools. And so in the example here, the little picture here, you have an admin. His global view, since he has access to everything, can see the cluster, can see the tenants or users resource pools. You have tenant 1, user 1, tenant 2, user 2. They have their own resource pools. They have their virtual machines, and they're just Kubernetes nodes, and that's what the admin sees. Now, if you have user accounts per user, what you can do is you can have those user accounts and apply RBAC to them and effectively give that user or tenant only access to their resource pool. So when they log into vCenter, they see the data center and the cluster, which is in read-only. And then you have read-write access to tenant one's resource pool. And they have their Kubernetes nodes, which are backed by virtual machines. And they're able, that user is able to add more CPU or memory to a given virtual machine, and they're able to shift around and allocate and create new virtual machines within their resource pool. And same with tenant two. Tenant two or user two has their credentials. They log in the vCenter server and they only see their resource pool. All the virtual machines assigned to that resource pool, and they don't intermix or commingle and have access to each other's slice of the pie in the virtual infrastructure. So what that looks like from the vSphere perspective, we've kind of talked about it logically. So we were actually looking at the vSphere UI using vSphere 7. You can see from the admin point of view here, you can see the virtual center at the top. Then you have the K8s DC, which is the data center. Then you have the cluster, and we have 4 ESX hosts there. And then we have 2 resource pools, one called tenant 1 and one called tenant 2. And each tenant has their own Kubernetes configuration. And so when you log in to the vCenter server using their individual vCenter account, and you have RBAC applied to them, you basically do RBAC through the vSphere UI and the vCenter UI, and you do the RBAC configuration there. So when you log in on the left-hand side, you have tenant 1 who logs in, can only see the tenant 1 resource pool and then their virtual machines there, which correspond to Kubernetes nodes. And then likewise, tenant or user 2 logs in with their creds, can only see tenant 2's resource pool and then their virtual machines. So that gives you an effective way of carving out resource, so compute resource, CPU memory, from a given set of clusters or a given set of ESX hosts, and carving them out to give them out to individual users. So now the question then becomes, so we have a good means of carving all that stuff out. So what happens when you have a given tenant or a given user where they have a large number of ESX hosts and they need to be able to carve out their own individual users and carve out their resource pool and dish out X amount of resource to one user or an business unit or an organization, and carve out some more resource for a different user. So effectively what I'm saying is what happens if we have tenant 2 here, user 2, they have a need for a large amount of Kubernetes nodes and large amount of virtual machines. And so what you can do is have more resource carved out and given to the tenant 2's resource pool, and they need to carve out and further subdivide that resource pool to individual users and business units. So what you can do is you can take that resource pool and effectively have nested resource pools in vCenter. And in this example here, it's tenant 1, and we're just going to ignore it. It's just the same configuration that it had before. And tenant 2 now says, hey, I have 2 organizations within my group, and we're just calling tenant 2 the engineering organization, and they have 2 groups within that engineering organization. One's the UX team, and then one's the backend services team. And so tenant 2 might decide to create 2 resource pools, one resource pool for the backend services team and then another resource pool for the UX team, and further subdivide the bigger tenant 2 resource pool into 2 other resource pools. And so what you do then is you create user accounts for those and apply RBAC to those individual sub resource pools. So you create a UX tenant or user account that can modify and have read-write access to the UX services resource pool, and then you create another user on the backend tenant or backend user account, which has read-write access to the backend services resource pool. And when you create the RBAC settings for that particular user, you can effectively, you have the color-coded what they would have access to when they have the need to manipulate resources and access to the individual nodes in Kubernetes. So the reason why you would do something like this is if you have one cohesive team, but you have that one is in charge of UX, and we have another team in charge of backend, but those services and individual pods that they implement are are tied together and you want them to be accessible without having to like route them through service mesh or like some other CNI mechanism, and you want them to be able to have access fairly easily to services and endpoints that are exposed by each pod that each team is creating. And this is like an easy way of like biting off that bullet. So here's an example CPI config for tenant 2. Kind of the most important things to highlight here are you have a vCenter section, and one capability that was added into CPI recently was the ability to specify tenants. And you have multiple user accounts within a given vCenter server section here, the section here. So, and the way you do that is you create two entries. The first entry, we're calling it tenant 2 engineering UX, which it represents as just like a tenant ID. And then you have the user account associated with that tenant or that user. And in this case, we're doing engineering UX. And then you provide a password, same vCenter server. You have a username, engineering UX, same, and then password. And then because we're talking about a single vCenter server, you're talking same server IP address and then also the same data center. And then on the right-hand side, you have tenant 2 engineering BE for backend services. They have their user account engineering BE at vSphere local, their password, same server, vCenter server, and same data center. And by having these two tenants defined in the configuration, vCenter server is able to use RBAC, and effectively for the CPI interface here, it's able to query based and get inventory for each user account, apply discovery through RBAC, but cohesively to the whole for the CPI, it's able to manage the entire engineering organization through a single configuration on the CPI. So that covers the CPI, and what that looks like in the CSI configuration, because you want to be able to keep the data, and when you're creating VMDKs or you're creating persistent storage for individual pods that are being deployed in your Kubernetes cluster for the UX team and the backend services team, you might want to do a configuration where you have two different CSI deployments, right? One CSI deployment and configuration where you deploy CSI just to the engineering UX team and just using the credentials for that particular UX engineering UX user account. So here, if you look at the vCenter server, you see the user, engineering UX, vSphere local, and then you do the same thing for the backend services team. So you have a second set of vSphere CSI deployment configuration YAML, and then the configuration looks like this, very similar with the exception of that the user account is different. And the reason why you do this, and this might be beneficial, is because when you create VMDKs and you do storage related operations, all the storage that's related to each account will be tied to that individual account. So you'll have the less likelihood that you have like PVCs that are called a certain name and have a collision between the engineering UX team and the engineering BE team. And so they are able to create their own individual PVCs without worrying about collision. And then at the same time, if there is collision, you don't have to worry about that particular VMDK that exists on the UX team get mounted and placed over on the engineering BE team. And it's basically because of these user accounts, you're going to have that restricted access so that it's only aware of the VMDKs that are associated with that particular user account. So what this looks like in terms of a diagram so that it's just really easy to digest. So if you have your vCenter server, you have your cluster, you have your tenant 1 has, it's just the same configuration that we talked about. It's used kind of just as an example for contrast. But cluster 2 is where we're talking about we have a larger engineering resource pool. We want to subdivide it to two teams, one UX team, one backend team. And we have two resource pools for each team. They have their own Kubernetes nodes. In the CPI configuration, right, we have both tenant user accounts listed in the CPI configuration so that it can have a holistic view of how it does workload placement within the Kubernetes cluster that's represented by the engineering team. But each tenant has their own CSI driver, and it has the benefits, like I mentioned before, it has the benefits of only providing access and mount capabilities for VMDKs that are associated to that user account. So to that tenant UX user account, to that backend services that user account that's for each individual CSI driver. It prevents collision, accidentally mounting other VMDKs from other users to other pods within their group. I have a demo for you, which actually is going to be the exact configuration that we have here. It's going to be a tenant 1, which is the very simple same CPI CSI driver for that one individual tenant. And then just like in the previous picture, we're going to have a tenant 2, which has two resource pools for a UX team and a backend team. And we're going to deploy a CPI driver that can manage engineering services team, and then we have two individual CSI accounts that basically create CSI drivers for each individual team to prevent access to each other's resources for storage. So my demo configuration here, I'm logged in the vCenter server under the admin account. I have a data center called K8s Data Center. I have a vSphere cluster called K8s Cluster with 4 ESX hosts on them. And just like in the PowerPoint presentation, in the last configuration, I have two tenants. The first tenant has a resource pool called tenant 1. It has a Kubernetes cluster already configured there. That resource pool has simply a user account called tenant 1 that's configured using RBAC to only see the resources underneath this resource pool right here called tenant 1. So tenant 2, we said that in the last configuration that we have to imagine that if tenant 2 was a very large Kubernetes configuration where it maybe required two different business units or two different teams working with each other, that we might have one engineering backend services and another team engineering UX to be underneath tenant 1 to subdivide the resources under this tenant 2 resource pool. So tenant 2, the resource pool here, configured using an account called tenant 2 under RBAC so that it can see everything underneath tenant 2. It has two subdivided resource pools. One engineering backend services configured with an account called engineering backup or engineering backend services, so that it can only through RBAC can only see these two worker nodes. And same thing with the engineering UX, can only see these two worker nodes under its resource pool. And so what we're going to do is we're going to configure the CPI or the Cloud Provider Interface for both of these tenants, and we're also going to configure the CSI driver for both of these tenants. In the first configuration, the first tenant, it's going to be fairly simple. It's going to be a simple CPI driver and CSI driver that gets installed. And for tenant 2, we're going to, just like in the last slide, we're going to install a CPI or Cloud Provider Interface for tenant 2, and that's going to manage the entire Kubernetes cluster, so all 5 nodes, so that it can set up zones. And then for the CSI driver, we're going to configure and deploy 2 separate CSI drivers, one for each subdivided team. So one for engineering BE, so backend services, another one for engineering UX. So let's go ahead and do that now. The top window here, I have logging into the Kubernetes cluster for tenant 1. And I have a simple script called tenant1.sh, which we can take a look at. And it very simply does exactly what I said. It's just going to go into the CPI folder, deploy the CPI for tenant 1, and deploy the CSI driver for tenant 1. And let's go ahead and kick that off. And then if we do a get pods, or kubectl get pods, all namespaces, we can see that we have a CPI or Cloud Controller Manager deployed for tenant 1 that's going to correspond and do all the work required to surface everything vSphere up into the Kubernetes cluster. And we have one CSI driver controller, which does the operations for like create and delete volume, and 3 CSI node pods, which handle all the mount operations for this given cluster for tenant 1. So now for tenant 2, we're going to go ahead and log in to the Kubernetes cluster that's represented by these 5 nodes, one master node and 4 worker nodes. We're going to execute a script called tenant2. We can take a look at that really quickly. For tenant2, because it's a little bit more complex, right? We said that we're going to deploy a CPI driver that manages the 5 nodes, the Kubernetes nodes. And the reason why it's important is because that CPI is going to create zones, regions and zones, so that we can divide the placement for where we want to drop things between either the backend services resource pool or the engineering UX resource pool backed by the Kubernetes nodes that are in those resource pools. And then, like we said, for the driver, the CSI driver, we're going to deploy 2 separate CSI drivers, one for the backend services team and then another one for the UX team. Go ahead and execute that script. And if we do a cube cuddle get pods all namespaces, we can see that we have one cloud controller manager, or CPI, gets deployed to manage these 4 worker nodes and 1 master node, and then sets up the zones for all of those hosts or nodes there. And then we have 2 CSI controllers, right? One controller for engineering backend services, one controller for the engineering UX. And then we have 1, 2, 3, 4, 5 nodes for each corresponding to if you're going to do volume mount operations on the 4 worker nodes and the master node. So there you have it. Thank you very much. I hope the demo you found was interesting. Like I always try to do, I always try to make everything available so that if you want to try this out on your own, you're able to do so. And you can find all of this on GitHub, so you can find it in the link there, all the scripts, all the YAML and everything. I included pictures there, so how you could duplicate the environment and go ahead and try this out on your own. And thanks a lot. I hope you enjoyed the presentation, and I guess we're going to be doing Q&A. Thanks a lot again.